So yeah, my goal with this webinar is to share what I've learned teaching students to program with Python, create video games, along with what I've learned for creating the arcade library for doing 2D graphics. So like if you're an educator, you work with interns or new employees, or you're interested in like the Typeending, that type of thing, hopefully you'll find some ideas to try here. If you happen to be a bit more of a visual learner or you like to follow along in written form, I've actually got the notes for what I'm going to talk about in the webinar, along with maybe some more detailed info. If you want to copy down that web address for later or to follow along, please feel free to do so. So anyway, like Paul Everett said, I'm a computer science professor at Simpson, and I've taught an intro to programming class using Python and Pygame for about 8 years. And I created a book out of it, a website, like websites here, and about 1,800 or so people use it each weekday to learn how to program. But Pygame got to be a limiting factor. I mean, it was sort of buggy and inconsistent, didn't use new Python 3 features, and eventually I got to the point where I was just spending too much time with students teaching the oddities of Pygame when I'd really rather just teach them how to program. So I created the arcade library to use these new 3D features, try to make teaching easier, and create faster games, and use the Typeending, that type of thing. And basically, I'm creating a new version of my program arcade games based off of that. So that's sort of a quick overview of where I'm coming from. Any questions, Paul Everett, so far before we get into tips?
Nope, there were some questions about why Python 3, and I said, stay tuned.
Exactly. Okay, so tip number 1, which isn't necessarily a technical tip, but leads into tip number 2, which is more on the technical side. If you ever train somebody, I really highly recommend spend time revising your teaching materials. I think one of the problems we've got with teaching materials out there on the market right now is people are writing books, how to program, they throw them out on the market without ever watching somebody go through on the front to the end cover learning how to program, which is kind of like releasing software and never testing it, in my opinion. And if you ever create any sort of training materials, actually watch somebody go through front to back, spend time revising that, do it again, realize it's not going to actually work well the first time, the second time. Sort of like software, it doesn't really work well until version 3. When I spent 8 years teaching Pygame, I spent so much time revising it that it was a lot of fun to create little things like when I had a question, I'd say, hey, if you think the answer is 0, because I had so many students over the years think the answer was 0, if you think the answer is 0, stop, go back to section 12.3, reread what we're talking about, and then come back here. And it kept people from the discouragement of missing the question and allowed them to actually learn the material proactively, because if they get it wrong, they never go back and reread. So my first tip is really spend time revising any sort of materials that you put together, because that is, I think, key to making a science and engineering process out of learning. So Paul Everett, are we okay to go on to tip number 2 where I start talking on the technology stuff?
Continue on. One of the questions was, are you going to show debugging? And as background on that, I did a 3-hour tutorial at EuroPython on visual debugging, and we used arcade and writing a simple arcade game as the topic. So you're going to cover anything about debugging?
Ouch. No, I did not have that on my schedule for stuff to cover.
No problem.
Inside of this time.
No, so for everyone else, we're putting together material about that 3-hour visual debugging, and we'll get it online.
Okay, so my tip number 2 is, if you're revising materials, use a really good tool chain for doing it. And I spent a lot of time working on different tool chains, and what I've come down to that I actually use for pretty much all my classes at this point is I end up using PyCharm as an IDE to write the material. I write it in something called restructured text, which, if you're familiar with posting like on Wikipedia or Reddit or something like that, you usually use something really similar called Markdown. Restructured text is a great way to write material without having to spend time too much worrying about formatting. I then use the tool that Python uses to generate its documentation called Sphinx. It's reasonably straightforward, provides decent documentation, and then I store everything in Git, and I often use read the docs, which can automatically pull anything that I push into Git and create the docs for me. This is a really fast tool chain, and it's nice because basically, now Sphinx is one of many different types of static content generators, but just because I'm sort of Python centric, Sphinx is built in Python and is sort of the official Python documentation creator. And I've got a lot of my websites, which you can look at on the online notes that you can actually link to. But the cool thing is you can go into PyCharm and also do builds, not just for Python programs, but if you create new builds, like you hit the plus button over here, there's a whole section in for creating Sphinx tasks and docutils as well. But I use Sphinx out of this, and then I can create my documentation. Like the documentation I created for this presentation is all done in restructured text. So if you want a headline, you just double underline it. You don't have to worry about unbalanced HTML tags. A headline 2 is just single underline. Bulleted lists are pretty straightforward. And you can build this, see all the warnings right there inside of PyCharm. PyCharm also has built in, if you spell something wrong, which is handy in a text editor, if you've got a link right here. So this is a link, and I can actually figure out what it links to, just like I would in coding by going to the declaration for it down here. If I create a link, whoops, I lost track of where I was at here, hold on. Long document. All right, if I create a link that doesn't link to anywhere, it'll actually underline and tell me it's an unknown target name. And being able to have PyCharm go ahead and give me hints right away when I'm not typing this in right is really handy as far as that tool chain goes. Plus, it's part of what I'm doing anyway for Python. You can include really quick code snippets. This is a really quick how you would include a code snippet. It's just one line and then the code snippet comes in afterwards. If you want to maintain a whole separate program and bring it in, so in this case I might have a bouncing ball program that I want to do, I can easily bring that in, add line numbers, and do that using Sphinx for putting stuff together. So I'll show it after here in a bit, but I've actually got a large number of samples and put the done using Sphinx and brought in as documentation. And it works really actually quite well as a way to write up stuff and creates rather pretty web pages out of it. So for instance, my documentation notes, I got the images in there. I got the ability to do small code samples really in any language and not have to spend a lot of effort on it. So that's tip number 2. Any questions, Paul Everett?
I want to kind of reinforce your point about Sphinx. That's also what I do for my training, like that 3-hour thing that I was talking about. And the way you use Sphinx in Arcade is very similar to the way I use it in my tutorials. There's a lot of value to being able to give people a repository that has both the docs and the working examples. And the code block that you mentioned, and the literal include especially, lets you keep the code separate from the docs, but include it into the docs. And so people can cut and paste if they have to. They can do a git pull and get the working versions of the code. It's a really good way to blend both sides of the equation.
Right. It is really easy to create sample code, paste it like into a Word doc or something, and then have it get out of sync with what code actually works. So yeah, you can keep live working code projects and then just use literal includes to grab them out, and then when you update the live code, your docs are automatically updated.
So three things that are coming in. One, they're asking if you're going to be doing coding later on. I know the answer, but I'll let you explain.
Yeah, actually, starting with tip number 3.
Okay. Next point is mostly for us, but I'll go ahead and answer it verbally for everybody else. Do you need any special edition of PyCharm to build Sphinx and RST, whether Community Edition Pro or EDU? The answer is no, it works under Community Edition. When I do my tutorials, my arcade tutorials and all the Sphinx stuff, I use Community Edition. Paul, do you want to talk about what you use in your classes?
Right. So in the past, I had used text editors, and I'll go into, as I was talking here, into the next tips as to why I end up switching and using PyCharm. Last year, I ended up using the full professional edition and had students get student licenses, which were free for the students and worked reasonably smoothly. Although, quite frankly, there's really nothing in the professional edition that the students, I believe, are using. So I'm thinking next year we'll end up using the community edition and encourage students to, I mean, with the student license, it's pretty cool because they can get access to everything, including like what they'll end up doing for their Java classes.
Right. And even after you graduate, we give a little bit of a discount as a graduation present.
So I don't know, it's pretty nice. And if I go into here, the reason why I've really enjoyed using this particular IDE, I can show here, but when students are programming, forcing them in a text editor to make sure everything is absolutely right, they get the right capital letters and everything, is frustrating, and it's not as enjoyable for the students. So when you create a program, like this is a sample program that uses the arcade library. I've done an import arcade, and if the student was typing the first line here, just the ability to do a type 2 when they hit the period, and they can come close to typing it in, and it will actually pop up what the actual command is. And I mean, the built-in idle that comes with Python really is somewhat just about as good as a stone tablet and chisel, in my opinion. But the ability to do this helps the student out quite a bit. They don't have to necessarily look up the documentation very quickly. Students have a real issue with text editors and not being able to spell, and they've gotten very used to having a spell check, and having the spell check built into the editor helps them quite a bit, and quite frankly helps my own sanity when we do that. The type hinting I'll talk in a bit, but even if they know what types of data they need to put in, the other thing that is cool is the built-in PEP8 checking. This is something that I thought students would ignore more than they do, but this is a normal line, but students who are learning to program might not know to put the space after the comma. And even if they were told you should put a space after a comma, the program runs without it, and it's one of the many things that they're being told and that just sort of ends up falling out. It is really frustrating for a student when they turn in a program, they've got it working, and then all of a sudden they're being told, and they're losing points because they didn't put a space after the comma, which to them seems trivial. But you don't want to graduate people that write code that doesn't come up to coding standards, because if you're a professional programmer and you get people in that don't indent correctly or space things out correctly, it's just sort of an irritation, so to speak. So the fact that this basically will pop up and tell them as they're typing it in that they need some additional white space here, it's less intrusive than an instructor. It happens while they're typing it in so that they don't have to go back and learn it. And I was actually really surprised to see how many of my students turned in programs that were completely PEP8 compliant or really nearly PEP8 compliant. I thought I would get like maybe 25% of the students, but actually like 80% of the students would really work to try to get most of the pop-up PEP8 warnings that happened. So that aspect was really nice in putting together the programs. The other thing that really like is we can easily pull up function documentation if you want without having to go to the web address. If you just hit Control Q and teach students how to do that, then it will actually pop up the Python documentation that goes with this particular command, which is really handy when students are learning. And let's see, for instance, down here, as far as typeinting goes, if I end up putting in incorrect numbers, like for instance, if I put in the title and then put in the numbers, it'll give me a warning right here that it was expecting a number instead of a string. It's easier for a student to catch the errors here than it is after you run the error and you get a stack trace. So it reduces the student's level of frustration by being able to do that. Colors are done in sets of 3 or 4, red, green, blue, or red, green, blue, and alpha. If a student were to forget that and just do 2 numbers for some reason, the typeinting can even basically tell them that something is going on that's not expected here. Basically, it's saying it needs 3 ints or 4 ints instead. So that has also been a real advantage in putting this together. So the program that I've got right here is just a drawing program. You'll note it does not include functions. I mean, it includes functions calls, but the student is not defining functions, which is important because I haven't taught them how to do function definitions yet. But this is just a typical student program. Whoops, ran the wrong program. This is a typical student program from the second week of teaching. And come on, run. There we go. So they've put together a guitar image, and they're actually able to see some sort of visual feedback. They're not just creating text programs. And it really captures a student interest when they're putting this together. And most of the students, basically, they're able to write rather lengthy programs for a second week and get PEP 8 compliance. Most of them are doing. And anyway, it's pretty nice. Let's see. Yeah, and the other nice thing is while you can declare functions and create classes to do stuff in Arcade, you can start doing stuff right away without having to go to that step yet. Any questions so far, Paul Everett?
Yes, here's a good one. What is the average age of your students?
The average age of students that I directly teach are college age, so they would normally be around 18 to 20. The program Arcade games, I've had a lot of high schools use it, and that would typically, and they've had a lot of success with it, so those would typically be 15 to 18. Really, I've not found people have a lot of success if you get a lot younger than teenage years. I think there are probably other tools that are a little bit better suited for that. But while I teach 18 to 20, I think this is reasonably well suited for mid to late teens as well.
For what it's worth, I have a teenage son, and I'm using Arcade to teach him Python. But I understand the point you're making. I want to come back to something you were talking about, stone tablets.
Mm-hmm.
In the world of PyCharm developer advocacy, obviously we go out on Stack Overflow and Reddit and answer questions and see what people are saying. And there's just this long, in the Reddit subreddit for Learn Python, there's a strong group of people that say you got to learn Python without any tools that help. No IDE, just use something extremely simple. I feel differently, not because my employer feels differently, but because I feel differently. I wonder how you feel about that.
I've done both, and one of my later tips I talk about sort of using IDEs, but the recent, basically I moved more towards I've done both on and off over the years, and There are disadvantages to using IDEs in that you sometimes don't have students realize what's going on behind the scenes, but it can be frustrating for a new student to have to learn all the behind the scenes things before they can create anything of use. The real kicker for me, quite frankly, was the whole PEP8 style checking and typeinting. I didn't think students would pay attention to it as much as they do, but the quality of code that I've gotten this year compared to prior years, it was just really surprising to me. And I get a lot of feedback from people online with new students, and if I happen to forget a space or if I do something that's out of Python compliance, I think the first time I put together some of my Python lessons, I had somebody tell me that I was absolutely corrupting people and that my students would be no good because I wasn't putting spaces behind the, commas, that type of thing. But it helps. I mean, it really helps the code quality, and then students get into good habits to begin with, rather than having to unlearn bad habits.
Right, and the kicker for me on that is, and I tell people this in the booth, I tell them about you and teaching, and some of these things are theoretical. Typeending will make an easier contract with beginners who are using your interface, your API. But you've actually done this and iterated on it in front of beginners and learned real-world carbon-based human lessons about it. And it turns out to be true about typeending, for example.
Yeah, I tried flipped classes with this, and I tried 3 semesters and learned that, for me anyway, flipped classes don't work. And that was a hard lesson to learn after sinking that much time into it. So sometimes you just experiment. And if you haven't actually played around with typeending, with any of these, you can go to the declaration of it. And it's not hard to add typeending to your functions to begin with. Basically, you've got your parameters. Here in this case, I've got width. Another thing that I've really found is that good parameter names really help new students, and good function names. Like Pygame uses set mode in order to open up a window. And just that right there confuses students. The coordinate system. Pygame uses an old classic coordinate system such as 0, zeros in the up left corner, but everything the students have learned has been the mathematical coordinate system where 0, 0, is in the middle, or at any rate, you don't have the y coordinates reversed. So basically, by eliminating a lot of that, creating decent function names, decent parameter names, not making them relearn the coordinate system, really saves a lot of time and lets you concentrate more on programming.
Yeah, and on typeending, because I also do TypeScript for WebStorm, and I gave a talk a couple of months ago, failing faster with TypeScript. And you've already shown this. When you put in a wrong type, the tool can help you. If you've put in the colon number here in your API, it can help you help your users.
Right.
You also showed Control Q to pop up the quick def, and we put the information in there. We're putting it in other places in PyCharm, like these pseudo badge looking things when you're calling to a function. And we have a real world example of this in RK. I say we. Am I allowed to say we?
Go right ahead.
All right. We, meaning you, changed the API for Open Window in the last release, right?
That's right.
You rearranged the arguments.
Because basically teaching out of it, I realized that the class had the arguments in an opposite order as the function. And
because of Piglet.
Basically, then that just became a little bit of another confusing factor for students as you're teaching them. And to actually use it, you just really kind of want to eliminate those.
But in this case, typeending helped a lot, because you're still passing 3 arguments, and without typeending, you wouldn't have known until you failed that you failed.
Right, and that's actually a Typeint is what originally brought me to realize that I was, even not doing it correctly. It takes a little bit of use getting used to doing type hinting. For instance, if I were to type in for coordinates, if you use int, then if you pass in a float, of course that'll be something that it's not expecting. Number pretty well copies or grabs both of those. Colors was being able to do a color was a lot more difficult than I expected, because you have to accept arrays and tuples and 3 numbers and 4 numbers. And so it's pretty easy to get started, because all you have to do is a colon and then a type after that. You import the typing library and the numbers library are basically the 2 built-in Python libraries that I use quite a bit for doing typing. And that's fairly straightforward, but then you start getting into where you can accept different types of data and you have to do a bit more thinking. But it's still not too bad, and it allows you to catch, it's sort of like having the static typing up front, the advantages of it without actually having it, still keeping the advantages of dynamic.
Yeah, and for people who can't bear their pristine Python eyeballs to see this type hint in their Python code, you can have a companion file called a stub file that puts that information in there. All right, on to some questions. Here's both a very easy one and one that has a lot of open source project poignant pain behind it. Does Arcade run on Linux?
Arcade runs on Linux. I've got it running on Linux. I've had it running on Macs. The real Achilles heel for doing this and really any other open game library right now is sound.
Ding, ding, ding.
There's no cross-platform support built into Pygame or Python, for sound, and there really aren't great libraries for it either. And boy, do I wish there was.
Yep. We're using one that's abandoned, and getting binary wheels is a pain. We're in good shape on Windows, in good shape on Mac, I believe, in decent, but it breaks constantly shape on Linux. The Piglet people have been working on a project for this, right?
Yeah, so if you're just interested in the graphics, it's pretty straightforward. Yep. But yeah, I don't have a quick solution on sound. It's one thing I wish that was actually built into Python itself.
Yeah. I actually offered a bounty in the Piglet user group to put in some money on it. Okay, on to Andre from PyCharm, our Typeending guy, has a really good question. He's also the team lead for Community Edition. Do your students write type hints by themselves? Do they understand the Python type hinting notation after your class? That's a good question.
That is a good question, and short answer, unfortunately, is no. That's not something I've tried or actually even really thought of. The amount of stuff that I need to get in their head by the end of semester, I really have not considered adding that to the mix. They get it in basically their second semester. Our second semester programming, they do Java where they have to declare everything. And that's been more of a subject that's covered in further detail on second semester programming.
Right.
A lot of
at the moment, the primary value is in the contract between Arcade and them, right? Yeah,
and the idea here too is this really is like a recruiting tool for us. And the better the less frustration we can give people, which the type hinting does help because they get to figure out their errors before they go on to the next line of code, makes students a lot more open to taking more programming classes and finding this to be interesting and entertaining.
Yep. All right, this is an easy one. What did you call the coordinate system that has 0, 0 in the center? The classic or something?
Cartesian. The Cartesian coordinate system is what I meant to say. Yeah, in Pygame, in Arcade, it defaults to 0, 0 in the lower left, and basically Y gets bigger as you go up, and X gets bigger as you go right. So you're looking in the upper right quadrant for what students have normally been taught in for math class. For old timers with computers, we got used to 0, 0 being in the upper left and numbers getting bigger as you go down. And really, even OpenGL does not operate on that coordinate system anymore. So there's no point in teaching old school coordinates.
Yeah. We actually have a lot of questions, and they're all pretty good. Is it okay if I continue?
Go right ahead.
Typeending is getting a lot of interest. This is one I have an answer to, but I think getting you to answer as well will be useful. So these type hints are defined by the creators of Python libraries, ? If they don't exist, is this something we can create ourselves inside the IDE? Lots of points to go on this. I'll let you go first.
Honestly, I don't know the answer to that. I think you mentioned that you could create a separate stub file, right?
Yep.
And I've not done that myself.
So I'll take a stab at some of the points on this. Yes, if you're writing your own code, then you can use typeending. And that sounds stupid because why do you need a contract with yourself? But I am a man of a certain age, and the future Paul is at war with the current Paul. And I need to leave some hints with the future Paul so that the future Paul doesn't get mad at me. I find myself doing typeending just to get stuff out of my brain. Do you ever feel that way?
I suppose that I tend to go a little bit more towards formal declaration. I spent most of my IT world in Java, and I'm a bit more used to doing things that way. I get a bit leery about, all of a sudden strings being held by variables that should have only been numbers. And also students sometimes reuse variables in ways that they are completely not intended to be reused for a different subject. And I would really like to get them out of that habit.
All right, 2 other points on this, and then the next question. You can, for your own code, the PyCharm debugger, if you run your code through the debugger and then go and exercise your application and then quit, PyCharm will record type information about all your function calls and then give you a quick fix to generate the type information for you so that you don't have to, which is really cool. For external
I did not know that.
Yep, that is really cool. It's magic. And then for external code that you don't have any access to, we talked about the stub files. There's also a Python project called Typeshed, which works to create stubs for programs that don't have them. All right, PEP 8 is great, but the underscores are so old school. There's a way to tell PyCharm to use camel case variables instead. I guess what the person means is, can I change my style rules to not complain when I use camel case instead of PEP 8 style? You certainly can go into PyCharm and suppress that as a warning. This one's for you. In your classes at university, do you use any version control?
That is basically what I showed you is what I do week number 2. Week number 1, I freak out everybody with version control. And I have a very specific reason on doing that, and basically it makes my grading a lot easier. I think it's important for students to actually begin to use it. It's built into PyCharm, which is nice. I also have them use Git and Bitbucket. I do that Bitbucket because they allow private repositories, and I don't really want them to show their homework answers to every other student that's out there. And it is probably the most difficult part of the class is getting them started on that, because it requires them to ask questions, and not all students like to ask questions when they get stuck.
Yeah, I think I talked with you about PyCharm's built-in local history option, which doesn't require them to think about a repository at all. People don't know it's there. It's really can save your bacon, has a nice UI on it, but maybe you just need to teach the formalism of thinking about a repository.
Yeah, when on the grading side, basically, I can then, with one script, grab every student's homework to check if it's all in a different repositories. Plus, I have them clone a repository that already has templates set up for them to basically start writing their programs. It's got the blank files and some supporting files too, if needed. So that has been reasonably successful, but yeah, version control is a heck of a thing to start with on week 1, but we do manage to get the students through it.
All right, we still have more questions, but let's continue and then save those for later.
Okay, so this was basically my tips 3 and 4. Tip 5, which does get into a little bit on what people were talking about before for questions. IDEs do have some disadvantages with working with students. So this is kind of how I get around that. If a student gets like a 2-line how to do a for loop that counts from 1 to 10, and you want them to run it, they just want to pop it in a file and run it. With an IDE, it can be a bit frustrating because they don't really want to create a new project, and then out of that new project, create a new Python file, and then finally plop in the program in order to run it. What I end up having the students do is create a Git clone. I actually have a folder with all the labs that they're going to create, and it basically just has blank files in these labs. And then they have an examples folder where I'll create some blank files, and they can easily create small files to run small snippets of code. And I teach them to do that. So if they only create one project for the entire duration of the class, then they only have that overhead like that first week when I teach them to do it. And it also makes version control a lot easier for them. The one thing that I really haven't figured out a magic solution to is it is not unusual for students to have a different program like this, and if they run it, as you can see right here, I'm going to run this program because I'm on a different configuration. Students do get confused about what program they are running. But in order to make IDEs easier, I strongly suggest getting the person set up with an IDE project to begin with, and then do all small sub-projects in folders underneath that. And in my experience, that has worked a lot easier. Then you get the code completion, PEP8 linting, and all that type of stuff in the code itself by using the IDE without some of the disadvantages. So
yeah, in my workshops, I do the same thing so that if they get behind or get messed up, they can teleport themselves into the present.
Basically, like for instance, I have a spell check lab, and I also include by default when they grab the Git, the dictionary, and they spell check like the first 200 levels of Alice in Wonderland. It doesn't really work too bad. It does just make getting set up that first week a little bit hairy, but after that, it runs pretty smooth. So basically, the other 2 tips that I've got that really I think help students learn is showing the API docs to students. I don't know why, but I think a lot of learning materials don't show API docs to students and give them that practice in learning to look up commands on the documentation. So I actually have API docs for the students. They can, so this is for the arcade library. I try really hard to create decent docs for the arcade library. So it's broken down into the different modules. If a student wants to learn how to create a filled parabola or a filled rectangle or an outline, they can quickly cruise through and see all the different commands that are available. And then they can go to the, let's see, polygon filled. They can actually see the command itself, the documentation that goes with it. I include examples on most of these on what it would look like to run it. And this is actually part of the unit testing. So the unit tests go through all the different tests that are built into the documentation as well. So yeah, one of the things I really recommend is if you're training somebody, even to like an in-house library, include a step where you actually spend time showing them the API docs and how to utilize them. Any questions up to now, Paul Everett?
We have a good number of questions. Some of them are more about arcade. So I don't know, are you going to get into a more full-fledged arcade example?
Okay, so let me go to tip 7 where I show examples of arcade.
Right.
Hopefully that
so
works.
Do you want some of the questions before we get into arcade?
Sure, go ahead.
All right. We'll try and keep some of them to be a little bit briefer as far as the answers. Do you have any experience using the Thani, or I don't know if it's Thani, IDE for Pygame?
No, I do not.
Sorry. How do you save the status of an arcade game? I don't think we have any examples of that.
No, we don't really. The one areas where I do get into showing students how to save statuses, I've got, hold on here, I got sprite examples, I've got sprite movements, I've got platformers, I've got, this might actually be an example that I have in Pygame rather than here. Yeah, it looks like it is. I thought I had the example here. I do have an example in my Pygame side where basically I show the students collecting different items in one room. They move to a different room, and then they move back to the original room, and how they can actually preserve the state of that room in a list. Because that is a question that I've had students do on a fairly regular basis. But now that I've got that question, I note that I don't have that particular example underneath the new arcade library.
Yeah, and arcade doesn't really, you and I were talking about entity component systems, which really separate the model data from the UI, which makes it a lot easier to just pickle or persist in some way the model data. So that's something maybe in arcade we got to look at more in the future. Kanpai Charm convert Python programs into standalone executables. This is as much an arcade Pygame kind of question as it is a PyCharm question. The answer is no for PyCharm, nothing built in. It's really a Python language thing, and there's PyInstaller, Py2Xe, different kinds of projects for each platform. Paul, do you have any experience from Pygame on that?
That's always been an issue with Pygame. Then there have been libraries with varying degrees of success to be able to turn it into a reasonable executable or installer or something that you could redistribute, especially because students in this type of framework often like to share their games with other people. And that's a hard question, quite frankly, with Python.
The Kiwi people do a good job at thinking about that, at least for targeting mobile.
Mm-hmm. And in particular, yeah, that really is though targeted more towards on the mobile side of the platform. But you do need your own Python install with the libraries that you're expecting to have. And yeah, that with the virtual environments and those other types of things has been something Python's worked with, but I don't feel like the solution is as clean as it really should be yet.
Yep. We got a few more questions. We'll take one of them and kind of segue into arcade. Paul, you're going to hate this one.
What do you got?
You're gonna think I wrote this question and pretended that someone asked it. Could multi-methods, multiple dispatch Python libraries help with game design and typeending? Ishmael, you won't believe this. Hopefully I'm pronouncing your name correctly. You won't believe this. I spent my summer vacation researching this for arcade. I looked at Reg and Dectate, two libraries from Martijn Fossen that are decorator-based registry and then multiple dispatch. I come from the Zope world. I have a lot of experience with this kind of design. So I'm going to be trying to persuade Paul to take a look at this, but for now, it's a work in progress. Paul, let's switch over to Arcade. Talk a little bit about Piglet. What is it? How does Arcade use it? And then get into showing off some Arcade.
Okay, so hold on here a quick sec. Let me pull up the example code. So basically, the Arcade library uses Piglet for a few different things. It uses Piglet as the interface for OpenGL. There is a separate library for OpenGL with Python. I originally started working with that, and I ended up switching because I like Piglet's implementation of using OpenGL. It also uses Piglet for managing windows and keystrokes, the joysticks. Piglet does a pretty good job of that. So the Arcade library builds off of that while trying to make it simple for first-time users. And the sound library, I try to basically do the same type of work that the Piglet library does. So basically, if you want to drop into some more advanced programming, you can go straight to OpenGL or use any of Piglet's features. And the Arcade library, though, is really designed around trying to make it easier for people to create arcade games without having to learn some of the complexities of a larger library. The sprite management is not Piglet sprite management. The Arcade library does its own thing for sprite movement, and that part is separate code and not shared with Piglet. Does that pretty well cover it?
Yep, sure does.
Okay, did you have a second part of that? I can't remember exactly.
No, it's just get into Arcade and show off some of the
Right.
simpler or more advanced games.
So one of the things that I have really found to be useful, let me zoom in here a bit, is showing people example code and teaching them how to go out and grab out of example code sections of code that they want to bring into their own program. Because this is actually how we learn stuff once we graduate. It's not all in a textbook. In fact, very seldom do we end up looking on a textbook. We look on Stack Overflow or find somebody else has done something similar to what we want to do. So the Arcade has a lot of example programs. We go through most of the drawing primitives. Here, there's actually a video walkthrough on what this does and how it works, along with an example that you can just copy, paste, and run that shows you how to draw a line strip, shows you how to draw a polygon, a filled-in polygon, that type of thing. Shows you how to draw with functions, because I don't assume in my teaching, because I have to teach students how to create functions, then I show them how to use functions, and it's nice because then they can figure out how to create a function that draws a tree, draws a background, and they can reuse that code in a visual context, because a lot of people are visual learners. How to draw text, do array back grids, which are nice in teaching students how to use two-dimensional arrays, and it also sets them up for being able to use Minesweeper as a game if they want to create that for their final project. Minesweeper is pretty cool because it also is a practical example of recursion, because when you click on a block and it does that sweep, that's recursion. And it's nice to be able to feature that in. So I show students how to basically animate a bouncing rectangle, do gravity, radar sweeps, draw with loops, create grids, lots of shapes, control things with mouse, keyboard, joystick, collect coins with a keyboard, face their sprites right and left. At any rate, we go through and they have example code for being able to do this. And this is all of these examples are basically from students saying, hey, well, I want to do this. If I didn't have an example, then I would create an example, give it to them, and then add it to the library for years later down the road. And it also makes sure that if somebody wants to use this just for a fun game that they put together as an idle project that you end up doing, you can see if you've got the functionality and how to do the functionality right away. basically shooting bullets upwards, aiming and shooting bullets. They end up having to use trig, so that's kind of fun. The sine cosine type of thing. It forces them to, or it gets them to actually see a valid use for trig. Having enemies randomly shoot, then they can end up figuring out how to use the modulus operator, because we basically periodically shoot does the modulus operator, excuse me, over a certain number of frames. At any rate, the arcade library can do quite a bit. It can also do platformers as well, where they can end up moving with walls. They can have a scrolling screen. Scrolling screen is so much easier than Pygame. For Pygame, you really have to like move the entire world while your player stays still. And with arcade, you can actually just move the coordinate system so that 0, 0 is no longer in the lower left, and that will move your entire world if you set your beginning coordinates. Show them how to work with output from Tiled, that program that allows you to create 2D grids. If you've ever used Tiled, it's a really nice way of creating 2D maps. They can do that. I also show integration with PyMonk. PyMonk is a 2D physics engine, which is kind of fun, where you can end up creating stacks of boxes. Whoops, I got a link that doesn't work there. Basically, you can create stacks of boxes, and it'll actually respond to physics. And at any rate, so we go through quite a few different examples. Game over screens are something that they don't necessarily know how to do to begin with, and on-screen timers, those types of things. So the end results on what students have actually been able to put together, I've got some quick video examples that I've run through. This is a guy that basically created a shoot 'em up platformer, one of the more advanced ones, but he's got little animations for walking back and forth, lives, he shoots things. It's not perfect, but it's not really bad for a first semester project. And whoops. Then this is basically a Buffy the Vampire Slayer, for anybody who's got a bit of age on them and likes watching that show. You have to collect stakes, and then once you collect stakes, you can stake the zombies first and then vampires later. And this was another pretty good one where you have to avoid the dragon, you're the knight, and you have to collect coins. You collect spears, which you can later use to throw at the walls. Avoid the fireballs, that type of thing. Again, not bad for a first semester student, I don't think. And this one, the guy did pretty good at actually doing instruction screens on it. And then these enemies have a health, so he's basically used the object-oriented programming to keep track of the individual item's health on the sprites so that they have to be hit by multiple missiles. And then as you go up different levels, the enemies can do different, become harder, basically. So let's see. Another one which basically shows you have to collect space junk, avoid asteroids, and you've got multiple lives. You've got a nice little fade in animation where you can't be killed during that initial rebirth, basically while you're spawning. Some pretty advanced features, actually, that students are able to program when they're putting that together. So sort of an overview on what students have managed to put together and what we've got for sample code out there for students to draw on. Paul Everett, you've got some questions on this or things I can go into in more detail?
Sure. First one's about teaching. Do you find that students using version control have less of the dog ate my homework when you can see the entire commit history?
Yeah, basically, it does help because occasionally you do get students that committed it but didn't submit the assignment for grading, and you can see online that the timestamps were that they actually did submit it, or if they didn't. I suppose I get fewer dog ate my homeworks and more issues with, oh my goodness, I somehow hit the wrong key and my program is gone, and now I feel incredibly depressed and that type of thing. It's really cool when you can actually pull the prior version out for the student.
Mm-hmm.
And I know that PyCharm's local history can do this too without even the student necessarily having to commit. That is a huge advantage. The disadvantage, though, is I do get, usually about once per year, some student who won't give me permissions to the repository, won't respond to any emails, won't acknowledge the fact that they're continuing to get zeros on their homework, and just basically then needs to drop out of the class. And it's really disappointing to lose a student on the repository side of things, but that's one of the frustrations I've worked with, but I'm not really sure that they would do that great in programming if they aren't willing to raise their hand in class and say, hey, why are you unable to grade my homework, at some point.
Yeah, you just did some future employer a big favor. Will you update or rewrite your book to use Arcade instead of Pygame?
Yeah, basically, the book right now, that link that I had on the tips, let's see if I can flip over here on the start. This is what I'm working on for rewriting the book, and it is all done in Arcade. I haven't actually created a print book out of it, but pretty much the material is there, rewritten in the Arcade format, and it will continue to be revised here as I start teaching from it.
Yeah, I highly suggest people looking at that. I looked through it, and it has the look of something that is not just good writing but good rewriting, because you've learned from what should work but doesn't versus what does work.
That is what I think is key to learning. I don't care how great you are. I think the first time you write anything, software, documentation, is just going to be terrible. You just have to realize you're going to have to change it 3 or 4 times before you get it right.
Yeah. Let's see. This is an interesting one. Do you think your course could be reformatted into a 12-week, 1-hour-a-week course for 6th through 8th graders?
You would have to trim down quite a bit what you manage to teach, but you are able to get a student to just draw images without even forcing them to declare functions. I mean, you can do, if you skip all the get stuff, I mean, you could have them doing that within like a few hours, really, right?
Mm-hmm.
And then from there, if you get them to do a little bit underneath animation, even inside of 6 weeks, basically where you've got a function that is called repeatedly and you show them how to add a little bit of math to move something further down the screen, that should be feasible within a shorter period of time. But you would probably skip, for instance, working with lists or loops within loops, types of things. I think you could trim it a fair bit and make it feasible.
All right. This is one I'll let you answer, and then PyCharm has an answer as well. Have you thought about using an online course platform for professionals who would like to do the same coursework your students do, or something similar to learn to program arcade games?
So our college uses the open source Moodle as their management, content management system for courses. And I did go through a period where I tried to put the documentation on Moodle, and it is not nearly as convenient as the Sphinx tool chain to create documentation. So what I end up doing is basically I create the materials here and then I just link to them on the online course documentation. I have students submit their Bitbucket link to their homework via Moodle, and that works actually reasonably well because Bitbucket has better tools than like Moodle would for marking up programs. And then I have a actually separate program that I use that takes a restructured like text format where I write my questions in and then converts them to a Moodle XML format for actually doing online quizzes. And That's fairly new for me, but I'm actually reasonably pleased at being able to do online quizzes that are auto-graded where I've got code formatting and syntax highlighting. But that's actually been a pretty hefty project of mine to try to get that shoehorned in there.
From the PyCharm perspective, we have a version of PyCharm called PyCharm EDU, which is backed by a learning platform called Stepic, and it allows you to create courses that are conducted inside the IDE, inside PyCharm. You have tasks, you answer questions, you get hints, you get graded. The professor can send it to a bunch of people, track their progress, all that kind of stuff. But it's primarily aimed at looking at the response of standard out. So from a Piglet perspective, watching an OpenGL canvas get manipulated is not how we can grade your results. But I've thought in terms of talking to Paul one of these days about, if we did moving the model out of the code, so to speak, more formally, then we probably could have PyCharm EDU and Stepic tell if you succeeded in a task. It's an interesting and hard problem.
Yeah, I'd agree with that. There's no perfect solution, I think, yet.
Yeah. You'd have to have tasks that were not really about what was happening on the screen, but were more about what was happening in the model.
And it's a different teaching style to do small programs with a predefined output, a rather valuable one. And in particular, I think that I like to hook students with doing the video games in the first semester. Our second semester is really standard IO based for programming, where it's easier to test how students' tasks work that way.
Yeah. Do you want to go on and show some more things, or do you want to take some more questions?
I would not mind taking more questions.
What's that?
Let's do some more questions.
Okay. How much more do you have, by the way?
Not much.
Okay.
Basically, I've got one tip left.
All right. Here's one that will take about 7 seconds to say no. Arcade on Android.
Yeah, no. Would be cool.
What version of PyCharm are you using for this?
I just downloaded your recent release.
Okay, so 2017.2. Basically, 2017.1 really gets you the full typeending that would be needed. That's it for the questions that I have for now.
Okay. I will then kind of finish up with one tip that I think is really important if you're working with newer developers, and that is basically take time to explain IDE features as you use them. Basically, if I just tell students how to use the feature, it doesn't really click in their head. And as the class goes along, when I'm moving lines of code up and down, I could just magically move them up and down. And the students aren't going to ask me in the middle of class, hey, wow, that's cool. How did you do that? They're just going to do it the way they know, where they go over here and they select it. And then they don't know the shortcuts. They do edit, and then they do cut, that type of thing. If as you are actually editing the program, you actually talk and say, hey, I'm hitting Alt Shift and up down arrows, let's move these lines of code up and down, then after a while, the students start picking that up. Indenting and unindenting blocks of code are also huge ones that students will do manually for quite a while until they start realizing how important that tip is, and they pay attention to you as you're up on the board, basically moving this back and forth. Multi-cursor is really big at saving time, and the ability to go over here and select multiple items, switch it into an asterisk instead, showing students that can save them a lot of time when they are working with their programs. And if you just do it without explaining what you're doing, saying, oh, hey, this looks like a great thing for me to use multi-cursor on, I'm just going to hit the Alt key as I click through some of these other ones here, then the students will eventually pick that up. And if they can program faster and spend less time with the menial duties of text editing, then they're going to enjoy programming and learn a lot better. Same as like the going to the definition or popping up the example docs, those types of things. Basically, even when you're looking over their shoulder, mentioning, hey, you can hit the Shift Alt and move your lines up and down type of thing. Spend some time teaching that, because it will help the students or even new programmers you've got in the office a lot in, just tons of time that you can not spend just doing that menial, I'm clicking, I'm working on this line, now I'll do the same thing on this line, and so forth. So spend time teaching that to people, because there's a lot of cool stuff built into any modern text editor, and PyCharm's got a lot of cool things in it. So that's about what I've got for my different tips. Paul, you got anything to add to that, or other last minute questions?
There is an infinity that we could show on teaching Python, an infinity we could show on Arcade, an infinity we could show on PyCharm with the whole combination. But maybe we'll invite you back for another demo later on. But people should keep an eye on Arcade, and people should participate. It is going to become a project with a really easy entry to participation. Would you agree?
Yeah, I would agree with that quite a bit. We've got a separate branch working on the 1.2 release, which will include a lot of accelerated options for the drawing primitives. And basically, I'm trying to flesh that out by creating a physics-based pinball game in order to do that. So, and the decorators as well as another project that I think actually would work really well for new students, because you don't have to learn object-oriented programming in order to use decorators. So it's a nice lower level of entry. There's a lot going on that we'd love to hear and get people's feedback on and contributions.
All right, and just to reiterate that, from a contribution perspective, it's neat being able to go and look at, say you're interested in gravity, say you're interested in collision detection. You can go look at some really clean code aimed at beginners. It's not boil the ocean code. It's modern Python 3.6. It'll all fit in your brain easily. It's just a good petri dish for learning and exploring. So very well done on Arcade.
Thank you.
All right, so I'll take over from here. Thanks, Paul, for taking the time to educate us on teaching Python. Did you see what I did there? Educate us on teaching Python. And about Python gaming. If any of you have any questions later, please don't hesitate to reach out to us by email or social media. We answer stuff on Twitter pretty fast. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar. Paul would love your feedback on this webinar. So when you get the survey, please feel free to spend 5 minutes and give us your thoughts on it. Contact us on Twitter and share your thoughts. The recording will be made available on our YouTube channel soon. If you haven't, please check out the PyCharm blog, subscribe to that. On our blog, you can find out up-to-date PyCharm news about releases and events, in addition to educational resources. So for example, the recording of this webinar with Paul will be published there in a few days. We'll also provide some additional links and information from the presentation on the blog itself. That's all from us today. Thank you very much for joining us, and hope you have a nice day.